All right, guys, so we have two more conic sections that we need to go over. So these are called hyperbolas. So we'll go ahead and get started. The definition of a hyperbola is the set of all points in a plane whose distances to two fixed points in that plane have a constant difference. So basically, if you take any point on this hyperbola here and you find the distance to each focus, and then you subtract those distances, whatever that difference is going to be the same for any point that you pick on the hyperbola here. And both of these parts, both of the parts in the blue, those curves, make up the hyperbola. Okay. The points that they use to look at these differences individually, it's called a focus. Together, they're called the foci. Couple more vocab terms here. It says transverse and conjugate axis. Again, we usually call them major and minor axis. So it's similar to that of an ellipse. It's a little bit different because we don't really consider the minor axis and the covertices as much, but the vocab words like those points and axes are basically the same. So the major axis for a hyperbola is the axis of symmetry that the hyperbola intersects. So this time, with an ellipse, we're drawing all 4 points and we're using all 4 of those points. This time, we're really only going to be using 2 of the points on the actual graph of the hyperbola. So the 2 points that are actually on the graph are always going to be called the vertices. Okay, so as you can see here and here, these are the 2 on the graph. Those are the vertices. These technically would be the covertices. The blue then would be the major axis, and then the red would be the minor axis here. The asymptotes are lines that the hyperbola approaches but never touches. So it's going to be these dotted lines right here. As you can see, we're going to use these lines to help us draw the actual hyperbola because it's going to be approaching those 2 lines forever and ever. So, I'm going to just have these up so you can pause it if you need to. But these are the equations, okay, for a hyperbola. You have horizontal and vertical hyperbolas. So I want to point out the major differences and similarities between these and ellipses. As you can see here, the setup is really similar, right? You have your x's, you can add or subtract, everything is squared. But you can see that for horizontal hyperbolas, the x is first, and for vertical, the y is first in the equation. Also notice that we're subtracting here, and that's the biggest difference between this and an ellipse. Ellipses, we're always adding. For hyperbolas, you're subtracting in the middle. It's still going to be set equal to 1. The center for these is going to be the same as before. You use H and K. Just be careful because before we got used to looking at just like looking at the first piece, right, and then the second piece, which is fine if it's horizontal and X is first. But over here for vertical, you need to look here first. What is being added or subtracted to the X? That's what goes first in your point for the center. And then you look over here at the Y's. That is the second point that you're going to be using. Okay. Also, one big difference is the equation for finding the focus, which is the same for horizontal and vertical. But with ellipses, it was a squared minus b squared equals c squared. Notice for hyperbolas, it's a squared plus b squared equals c squared. So kind of what I use to remember it is I look back at the original equation. If the original equation has a minus, then I'm going to be using plus in my equation to find the foci. A, B, and C are the same as before. A is always the distance from the center to the vertex, B is the distance from the center to the covertex, and C is the distance from the center to the foci. But notice where A and B are. Before, for ellipses, A was always the biggest number. That is not true anymore. For hyperbolas, A is always going to be used first in your equation. Okay. So another thing to point out, with horizontal ellipses, the x comes first. So when the x is first, that tells us that the hyperbola is going to be opening left and right. Okay. For the asymptote here, And we're only going to be looking at the asymptotes when the hyperbola is centered at 0, 0. So these dotted lines right here are the asymptotes. So we're going to have two equations. They're going to be the same. One's going to be positive, one's going to be negative. And basically think your y-intercept is going to be at 0 because it's going to be centered at the origin. So we just need to figure out the slope. Think rise over run. Okay, so you're going up b units and then over a units. So b over a is going to be the slope. So we multiply that by x, and then we said the y-intercept is 0. So that's all we need to put there. Okay. For vertical ellipses, the y is going to come first in the equation, so that's going to tell us it's opening up and down. So here's our asymptotes. And so what we're going to do is we just need to find our equation by basically finding the slope again. So it's going to be plus or minus. This time you're going to go up a, so rise over run, so it's going to be a over b times x. And honestly, the way I remember it is by just thinking about rise over run. So think what's under the y value. That tells you how far up and down we're going, so that comes first. And then what's under the x value. Okay, so here we go. We'll go ahead and identify some things first. It says identify the center, the vertices, and the foci, then write the equation of the asymptotes. So a couple things I want to point out here. First, because the x is first, that tells us that it's going to open left and right, so it's going to look something like that. Okay. The center is at 0, 0 because there's nothing being added or subtracted to the x or the y. So for the vertices, you're always going to look at, again, what comes first. Because the x's come first, it's opening left and right. So these points here are going to be the vertices. So remember, you always take the square root of what's underneath here. So the square root of 4 is 2. And that tells us that from the center, I would be going left and right 2 units. The x value is what comes first. So the x value of the center is what's going to be changing. So I'm going to take that value of 0 and add 2 and subtract 2. So my vertices here are going to be at 2, 0 and negative 2, 0. Okay. They don't leave a spot for the co-vertices on these because the co-vertices aren't even on the graph, and so we really don't care about them as much. So they're really only going to be asking you for the vertices and the foci here. The foci are always going to be found on the same axis or the same line as your vertices. They're always going to be like inside of the hyperbola. Okay, so to find where those are, we have to use our equation. Remember that because I'm subtracting here, I'm going to be adding for my equation. So a squared plus b squared equals c squared. A squared is going to be 4. Remember, it's always the number that comes first in my equation at the bottom there. And then plus 25 equals c squared. So 29 equals c squared. Take my square root. That cannot be simplified. So square root of 29 is c. So it's the same type of situation here. It's still the x value that's going to be changing. So I'm still going to take that 0 plus root 29 and 0 minus root 29 to find my new x value, which is just, plus or minus root 29. So my foci are going to be at negative root 29, 0, and positive root 29, 0. Okay, and then the last part is finding the asymptotes. So again, I want to think rise over run. It's always y equals plus or minus, and then I need my slope, rise over run. For the slope, rise comes first. So that's up or down, which tells me that I need to look at what's under the y's. So I take my square root of 25, which is 5. That's the rise part. The run I get from the x's. I look under the x's. Again, take the square root. That gives me 2. Okay, so I would be going up 5 units, right 2 units. So there is the equation of my lines. Okay, so same type of thing here, except now notice that, look, the y's are coming first, right? Which means that the hyperbola is going to be opening up and down. So it's going to look something like that. My center is still at 0, 0. I'm not adding or subtracting anything to my x or my y. Now for my vertices, I'm going to be looking again, since the y's come first, it's the y that's going to change here. I take the square root of 36, which is just 6. So I'm taking that 0 and adding 6 and subtracting 6. So my vertices are going to be at 0, 6 and 0, negative 6. Okay, foci, I need to use my equation again. So it'll be 36 plus 9 equals c squared. So 45 equals c squared. This one I think I can break down. So 9 and 5, and then, yeah, 3 and 3. So c is equal to 3 root 5. You can take out that 3 there. So again, it's still going to be the y that's changing here. So I'll have 0, 3 root 5, and then 0, negative 3 root 5. For the asymptotes, it's always y equals plus or minus. Again, rise over run. So I look under the y's first for rise. That's 6. Under the x's, take the square root. That's 3. So this can actually be simplified here. So y equals plus or minus 6 over 3 is just 2. Okay, so y equals plus or minus 2x for my equation of my lines. Okay, we'll do a couple where the center is not at 0, 0. So, and notice we don't have to find the asymptotes anymore. That becomes a little tricky when it's not centered at the origin. So to find my center, again, I look at the x's first. I'm subtracting 2. Remember, I switch my sign, so it's a positive 2 there. Then I'm adding 3, so I switch my sign to be at negative 3. Okay, my vertices. So again, I look at what's first. The x's are first, so it's this x value that's going to be changing from the center. I look underneath. That tells me I'm going to be going left and right. Square root of 1 is still just 1. So I'm going to take my x value of 2 and add 1 and subtract 1 to find my new x values. Okay, so my new vertices here are going to be 3, and then I keep my y value of negative 3. My second one will be 1, negative 3. And then for the foci, again, it's going to be the x value that's changing when I go back to my center, which is kind of my starting point. So I need to figure out how far left and right I need to move to find the foci. So I use a squared plus b squared equals c squared here. So 50 equals c squared. Okay, break this down. So c is equal to 5 root 2. So then, again, from my starting point, which was 2, I'm going to be adding 5 root 2 and then subtracting it. Now, you can't combine these because one has a root and one doesn't. So these are just going to be my new x values. So my foci are going to be at 2 plus 5 root 2, negative 3, and then 2 minus 5 root 2. Negative 3. Okay. And then last one of these. So really be careful here. This is probably the most common mistake, is that people want to say that the center here is at 1, 8. But that is not right, because we always have to look at the x first. And so the center here is actually at 8, 1. Okay, always look at the x first. Now, the y is first here, which means the y value is what's going to be changing when I find my vertices and my foci. So I look under the y, that's 9, so square root of 9 is 3. Okay, so that's what my vertices are going to be changing by. So I need to take that 1 and add 3 and subtract 3. So my vertices here are going to be at 8, 4, and 8, negative 2. Okay, and then one more time, do the a squared plus b squared equals c squared. Simplify this. So I can break this apart. C is equal to, I can take out a 3, so 3 root 10. And again, it's that y value, that 1, where I'm going to be adding and subtracting the 3 root 10. Okay, now these are going to be my new y values. So my x value is still going to be at 8, and then I'll have 1 plus 3 root 10. Whoop. My second one will be 8, and then 1 minus 3 root 10. All right, so then let's move on to graphing. It also wants us to name the center, vertices, and the foci, but we'll kind of fill those in as we go. So the center here, we start there. You're not adding or subtracting anything to the x's or the y's, so the center is going to be at 0, 0, so we can make our center point at 0, 0, okay? What's the same as graphing these as with ellipses is that you still look under the x to tell you how far left and right, and you still look under the y's to tell you how far up and down. And you still take the square root. So we'll take the square root of 16, that gives us 4. Square root of 25 gives us 5. So from the center, I'm going to go left and right 4, make dots there, and then up and down 5. Now with an ellipse, you would just draw the oval and you'd be done, okay? It's different with a hyperbola. From these 4 points, you are going to make a square. Once you have this square drawn, you're going to draw the asymptotes. That's going to be 2 lines that cut through the corners of, it's not a square actually, it's a rectangle. So the corners of the rectangles, okay? And it also should go through the center. These are the asymptotes you're going to use to draw your hyperbola. So now I'm going to switch colors because technically none of this is actually part of the hyperbola. It's just what we use to help us draw it. So I'm going to switch colors here. Now, because the x is first, that tells us that this hyperbola is going to open left and right. So I'm going to go to my left and right points here at -4 and +4. And then to draw the hyperbola, I'm going to just draw that curve approaching these 2 lines that I drew, the 2 asymptotes. And it does actually touch that point at -4, 0. It does touch that the vertex. So then I'm going to do the same thing over here. Again, approaching these lines that I drew. And then that, just that dark blue, that is the graph of the hyperbola. Okay. My vertices then are at -4, 0 and +4, 0. And then my foci, so again, I just need to use my equation here. So 16 plus 25 equals c squared. That cannot be broken down. So c is equal to the square root of 41. So since your center is at 0, 0, you'd be adding and subtracting that to 0. So it'd be -√41, 0, and +√41, 0. You do not have to draw in the foci, but remember if you did, usually they draw them as like stars. They're always going to be like outside of your hyperbola, somewhere around there. Okay. Let's draw another one here. Okay, so we're going to start by changing up my equation a little bit, right? I don't have my fractions that I need. Also, this has to be equal to 1, so that's why I'm going to divide by 400 so that on the right-hand side it does end up equaling 1. So when I simplify these fractions here, I will have y squared over 25 minus x squared over 16 equals 1. Okay, so I know again my center is at 0, 0. I'm not adding or subtracting anything to the x's or the y's. So I'm going to start by plotting my point at 0, 0. Careful, I look under the x's to tell me left and right. So that's the second piece here. So I'm going to be going left and right. Again, I take the square root. So left and right 4. Up and down, I look under the y's. Take the square root. So up and down 5. Process is the same here. I'm going to draw my rectangle through my 4 points. Draw the asymptotes, so the best that I can, draw my lines cutting through the corners. Okay, and I'll switch colors because this is going to be the actual graph of the hyperbola. Remember to tell which way it's going to be graphed. I look at what comes first. The y's are coming first, which means this is going to open up and down. And so I know I'm going to be graphing these points up here. Go down to the bottom, do the same thing. Draw the curve that approaches those 2 lines that I've drawn. Okay. My vertices, again, vertices are the 2 points that you actually use on the graph. So that was how far up and down we went from the center. So that is going to be at 0, 5, and 0, -5. And then my foci, again, I have to find the value of c. So 25 plus 16 equals c squared, same as what we just did here. So c is the square root of 41. This time it's just going to be the y value. 0, square root of 41, and then 0, negative root 41. Okay, last one we'll try. This one is not centered at the origin, so the process of graphing it is the same. So we still start with our center here, which again, careful, look at the x's first. So our center is actually at -3, -2. So we'll go ahead and start by putting my dot there, -3, -2. Look under the x's to tell you left and right. Again, take the square root, so we're going to go left and right 2. Up and down, you look under the y's, so up and down, take the square root, so up and down 3 units. From here, you're going to go ahead and draw your rectangle. Okay. Again, do your best to draw your asymptotes, cutting through the corners and the center. And then you're going to go ahead and draw in the hyperbola. Since y's are coming first here, that tells us that it's going to be opening up and down. Okay. So there we go. There's the graph. Now, since we have this graph, to find the vertices, you can either just look at the graph, right? I'll put them in green here. Remember, the vertices are the 2 points that we actually graph from those points that we draw from our rectangle. So you can see that this first point on top is, you go left 3, up 1. So -3, 1. And then -3, let's see, how far down am I going here? 5, so -5. But if you wanted to just use your equation to find that, I get that from taking the original starting y value, which was at -2. We said we went up and down 3 units. So I'm adding 3, and then I'm subtracting 3. And that's what gives me the 1 and the -5 that I'm using. Okay. And then last is finding the foci. So I have to go back up here, do my a squared plus b squared equals c squared. 13 is c squared. That cannot be simplified. So c is equal to the square root of 13. Again, it's the y value that's going to be changing from the center. So I'm going to keep my x value, take my y value and add root 13, and then subtract root 13. Okay. And that is it for hyperbolas. We're just starting with graphing, finding your center, vertices, and your foci. So homework for this is that Hyperbolas Day 1 worksheet. Please email me if you have any questions over this. Okay. All right, that's it. Thanks, guys.